Assalamualaikum warahmatullahi wabarakatuh. So this is additional notes or additional explanation on how to actually use what we call uh, 2 meter watt. Okay, 2 meter watt method in measuring the three-phase power. So actually there are two methods. The first one is we are using 3 meter watts. Okay, so each meter watt is connected to its phase, and then the total three-phase power is just a summation of all the watt-meter reading. Okay, and the second one that we want to actually discuss a little bit is on the 2 meter watt. Okay, 2 meter watt method. So as you can see here, we have only 2 watt-meter to measure the total power of the three-phase, where the total power of the three-phase can be computed by total up the reading of from the watt-meter 1 and watt-meter 2. Okay, and as you can see, the common point is actually connected at phase B, but it is actually can be any phase. Okay, the common point can be any phase, whether it is A, B, or C. Okay, so to actually the watt-meter here, the first watt-meter is actually, as you can see here, the reading of the current is actually I line. Okay, from the watt-meter number 1. Okay, and the voltage that they will measure is also V line, which is I line which is IA, and V line is actually VAB. Okay, and what is actually the reading from this first watt-meter? Okay, so we assume that the complex power from this one, okay, is actually, we assume that it is VRMS multiplied with IRMS conjugate. Okay, and this VRMS, the reading is a V line. Okay, so V line, but the angle here, okay, when referred to the V phase, we know that when V phase is a reference where the angle is 0, so V line is always leading the V phase by 30 degrees. Okay, for the Y connection here. So we put this one 30 degrees, and then multiply with the IRMS is your I line, and for the Y connection here, the I line is your I phase. So and the value of the theta is depends on the what we call the phase impedance. Okay, the phase impedance, and usually the current will always by referring to the reference VAN as a reference where the angle is 0. So usually VAN, okay. So usually the angle is negative. The current is always lagging. Okay. So we put this one negative, but as you can recall, this one should be conjugate. So meaning that our complex power is VL IL 30 degrees, and because it is conjugate, so you need to actually convert into plus sign, so theta. Okay, so from here we know that this is a complex power, so we only extract, or we only write down the what we call the equation or formula for the average power, the equation or the formula of the average power, which is the real part of these complex numbers, is VL IL cos 30 degrees plus theta. Okay, I think this one maybe it's appropriate to put theta first, theta plus 30 degrees. So this is the reading from the first watt-meter. Okay, and let's look at the second watt-meter reading. Okay, the second watt-meter reading, which is from, Okay, meter number 2. The measurement of the voltage and current is same, but right now the voltage that they measure is V line, which is VCB. Okay, and the current that it measured is the I line or also I phase for this type of connection, which is IC. Okay, and we know that VCB is actually a negative of VBC, or you can also actually write down actually VCB, or you can actually what you call derive VCB is actually VCN minus VBN, where your VCN is actually when referring to the value of the phase is actually VCN is actually 120 degrees different, and while for the VBN is VBN. Sorry, I think we put just V phase here, and this is also V phase. Or maybe V line is VAN is okay. So VAN, this is also VAN, but the difference is 120 degrees. And when VCB, okay, you will see that okay, the value here is actually VCB is equal to V line with an angle of 90 degrees. Okay, so we can put here as this one is actually a V line with an angle of 90 degrees. Okay, and IC when referring to the VAN is actually an IA with an angle of 100 minus theta. Okay, then or I can also write down this one is just an I line. Okay, so sorry for this one. Okay, so the complex power from the second wattmeter reading, so we assume that it is RMS, so VL multiply, sorry, VL with the magnitude 90 degrees multiply with the IL conjugate. Okay, conjugate within that you have this one IL with a theta minus 120 degrees. So you will have the angle is actually VL IL with an angle of 90, so theta minus 30 degrees. Okay, so we extract the real part of this complex power, so we will have, which is VLIL cos theta minus 30 degrees. Okay, so the total power for the three phase is actually P1 plus P2, which is if you calculate, you can actually call that this one is a VLIL cos theta V minus theta I. Okay, so that's all for the additional notes on the 2 wattmeter reading.